Hi, I'm Jose Conchello, and welcome to TuneCraft. I designed and developed TuneCraft as my final project for the Wearable Devices and Computer Vision class here at the Harvard Extension School's Digital Media Design graduate program. TuneCraft is a creative technology project that integrates 6D object pose estimation with dynamic audio control for immersive and interactive digital art installations. TuneCraft relies on real-world hardware in order to achieve its immersive art experience. Okay, so a little bit about our hardware setup. We have this laptop which is running all of our software, so we have TouchDesigner running here that is reading its MediaPipe scripts from these VS Code files which are in Python. And then we have Ableton running up here, which is being communicated to via TouchDesigner. And then we have TouchDesigner outputting its visual UI to an HDMI splitter. That HDMI splitter sending one video feed over here so that I can proof it while I'm working on it. And then we also, if we follow this cable, it goes all the way up to our projector and camera setup. So we've mounted the camera on top of the projector so that we have the best possible mapping of camera to projector. And then that is being projected here on the ground. Our first point of entry is TouchDesigner. TouchDesigner is a node-based visual programming language for real-time interactive multimedia content. In this project, we are using TouchDesigner for three primary tasks: running computer vision scripts, broadcasting parameter changes to Ableton, and generating the UI for projection. So first, let's do a little walkthrough of our TouchDesigner patch. We have our video coming in through our webcam, which we are then routing. First, we route to our ARUCO marker detection script, which is going to detect the markers that are being projected on the ground. You can see those here. So once I enable this script, it will find those markers. And then once I enable this script, it's going to use those markers and crop the video output so that it matches the camera and the projector viewport. And that way we have a one-to-one between what the camera sees and what the projector is projecting. So we can see that this changed and it updated the UI, so now we are tracking our object in 3D space. So now that we have the ARUCO markers in play, we see that this operator is cropping our video from the original to the new space, which this is what we now use. We have a smaller video that is being put into our object detector. This object detector is running a Python script with MediaPipe, and we are using MediaPipe to get the positional data. So you can see those channels are like more or less populating here. We are using this hold operator so that we hold those values and it'll update every time it turns back on. So with MediaPipe, we have to tell it specifically what we are looking for, unlike YOLO object detection, which has a set list of objects that it can and will detect concurrently. With MediaPipe's Objectron, you have to specify what object and how many objects to count. So right now we have this shoe set to a total of 1 shoe's maximum. We also have the detection confidence down fairly low. This makes it more responsive to changes in the environment, but the downside is it will pick up other things and it'll be noisy. So like, it's going to pick up that for a little bit. It doesn't know what to do with it. I can raise this detection value up higher, and then it will kind of stop finding things because it's just looking for too perfect of a match to do anything with that. So for that reason, we are keeping the detection confidence low and the tracking confidence in the upper middle ranges so as to get better values for our X, Y, and Z rotation. So a new feature that's been added on this round of TuneCraft is a no object detected trigger. So how we're accomplishing that is, you'll see in this object channels, we have no data. And so this pipeline is looking for changes in how many channels we're getting. So we get the number of channels from here. And then when there are no channels, we then trigger the timer to start. So we have a 5-second timer, and if within that time we do not see an object detected, we set the variable of no object to true, and then that variable is passed around to various elements. So first and foremost, we pass it on to the Ableton exporter. So what this does is once there's no object detected, we are using it to control the master volume. So when there's no object detected, the volume will go down. And on the other side of things, in the UI, we are using it for a couple things. So we get that value here, and one, we will turn the bounding box here in red if we don't find an object, and additionally we will set the no object detected text to pulsate over the frame, and that is how we are using the no object detected feature now. So once we get through that, we are now splitting our individual channels that we've found. So we are getting the centroids up here and the rotational data here so that we can process them separately. We then map them to their value space, and now we go over here to our TouchDesigner Ableton section, where we are going to take all these values and export them into our Ableton instance, which is up here. And so changing these parameters will change parameters of this Ableton composition. So here we see one of the limitations of MediaPipe's Objectron. It becomes really noisy when trying to calculate the rotation angles. You'll see that the shoe is not moving, and yet we are getting insanely different results that are just going all over the place, and it's impossible to denoise the signal real time because we don't have associated values around with which to use as our barriers. So due to this limitation, we've mapped some of the less jarring attributes in our Ableton composition with these rotation values. So the X in red is going to be modulating which melody clip we are playing. So we have a variety of melody clips playing. You'll see that here being updated in real time, kind of sporadically. Those are the instrument rack clips on the right. Next we have the Y rotation in green, which is going to be changing the tempo, which you'll see modulating up here a little bit better than the X is. And lastly, we have the Z rotation in blue, which is going to be controlling the amount of effects that we have, which you can see here, that little orange dot. You'll see that's just wild. Additionally, we have 4 different instruments that are mapped to the Y position of the shoe. And then on the X position, we have a number of drum clips that it will trigger based on its X position. So the further to the left, it'll play higher up, and the further to the right, it'll play lower down. So right now, since the shoe's in the middle, we're playing the Arkham clip, and if we move the shoe to the right, we'll get the Kyoto clip. So in addition to getting these centroids and rotational data mapped to Ableton, we also send these out to our UI composition, which is up here. So the UI tracker basically has a spotlight that is running over our 3D object. So we use the centroid position for the spotlight, and then we are splitting the channels for the X, Y, and Z and getting those rotational positions mapped out as these different red, green, and blue arcs that map onto the projected surface. And we can see that over here as such. And so if I move this guy over here, the camera should follow him. It's a little laggy, but that's fine. Okay, let's take TuneCraft for a drive now. The application starts with no object detected because, of course, it's not detecting any object. But as soon as we throw the shoe in there, it'll start detecting something and magic will start happening. As we move the shoe along the X-plane, we'll notice a change in the drum patterns that are happening, and you can also see that in the upper left-hand corner in the Ableton. You'll see in the teal section, the marker will move as we move the shoe from left to right. And as we move this shoe up and down on the Y-axis, that'll change the instrument that is playing. And as I rotate the shoe, you can see that in the blue column, the track that is playing changes, and in the black box, the little orange icon moves to signify change in rotation. Now if I remove the shoe from the camera's view, you'll see that the no object detected screen comes on. And then once I put the shoe back in, the song immediately starts again. As a final thought, I think that MediaPipe has the potential to reimagine how we interact with space, but for more precision-based applications, I think MediaPipe still has a long way to go, especially with rotational data. And that's it, and thank you for joining me on this musical computer vision-driven journey.